recording. Okay, let's see that what we have here. This is basically the chemical kinetics or the chemical reaction relationship with the rate of reaction. At very first, we have the definition regarding what the definition is related to the rate of reaction. Now, what is the rate of reaction? If I ask you that the word rate, we know about the chemical reaction and the word reaction, but we need to understand the concept of rate here. If I ask you that your friend bought a car and you just go to his or her home and ask her that what is the speed of this car, and he or she will surely tell you that, let's take an example, that 60 kilometers per hour. Okay, so if you uh, make the distance in a very little sense of time, it will become the 1 kilometer per minute. Let's say that minute is the smallest unit. Not the minute is the smallest unit. We consider always seconds as the smallest unit of time. We always consider uh, reactions and all the aspects in the seconds. But in this example, if I'll be going in the seconds, it will go very irrational value. So that's why I'm saying that 1 kilometer per minute. It is basically the speed of this car for moving. So what is the rate of reaction? If I say that the rate of reaction is also known as the speed of reaction, or if I say that speed of reaction also known as the velocity of reaction. So if I ask you this thing, that a person is just standing here at the point A and he wants to go to the point B, and he just consumes, or we can say he spent 10 minutes here. Okay. So there is a time taken for the change to happen, that the person will move from position A to position B. This is basically the rate at which the person is traveling here. If I'll consider this distance in the kilometers or meter, we'll get the value. So what is the rate of reaction? So the rate of reaction is the change in concentration of reactants or products in unit time. That is the main thing here. Unit time is the main thing here. Okay. But if I ask you that, if I'll be writing a formula for rate of reaction, it will be like rate of reaction is equals to change in concentration of reactant or product divided by the time taken for change. Are you getting my point?
Yes,
That
sir.
whenever you say that the rate of reaction, it means that you are discussing about the change in the concentration. And what is concentration? Zair, what is
The
concentration,
amount,
bete?
the amount of
Exactly.
reactant or
The
product.
very simplest explanation, a very simplest meaning of the concentration is the amount of substance. Okay. Let's say that when we are discussing about any of the chemical reaction, we know that the reactants will convert into a product. Am I right? Let's draw a graph for it and then we'll understand that what is happening here. Okay, let's say that we have time here and we have concentrations here. Say that we have reactants. When the time is zero, reactants is the max. Reactant is on max. And we have
Yes.
products which are zero here. Okay. Okay. With the passage
Okay.
of time, you know that the reactants will start decreasing. Okay. Reactants start decreasing, and eventually, on the other hand, what is happening? What is producing? The product starts producing. Am I right? So if I say
Yes.
that the reactant is decreasing and you're saying that the product increasing, we both are same. We both are just giving the concept of a same thing, but in the different context. Am I right? So the thing is, the
Yes.
reactant consumes, so the product will produce, and the change which is happening in the concentration of reactant and the change which is happening in the concentration of product in a particular unit time, that is known as the rate of reaction. Is it clear,
सर
Bete?
एक सवाल था।
हम्म।
मैं एनोटेट करके दिखा सकती हूँ आपको?
हाँ हाँ हाँ, करो करो करो।
लाइक आपने ये जो इस तरीके से आपने इसको ड्रॉ किया है, आपने इसको ऐसे क्यों नहीं कर दिया?
हम्म, मतलब यूर सेइंग दैट कि मैं ये वाली लाइन को ऊपर ले जाता और ये वाली लाइन को नीचे ले
जी।
जाता, तो
नहीं
अगर मैं
नहीं,
ये करता।
रिएक्टेंट वाला तो आपने ठीक किया, प्रोडक्ट वाला आपने वैसे क्यों नहीं किया?
प्रोडक्ट वाले को मैंने ऐसे क्यों नहीं किया? ये।
जी। जी, क्योंकि
अच्छा
दैट वाज
देखो,
इंक्रीजिंग ना।
दैट इज ऑल्सो इंक्रीजिंग, बट द मेन थिंग इज कि हमारे पास जब रिएक्टेंट डिक्रीज हो रहा है, प्रोडक्ट इंक्रीज हो रहा है, दोनों कॉन्सेप्ट अपनी जगह सही है। लेकिन अगर मैं ग्राफ को इस तरह बनाऊंगा तो यहाँ पर देखो, विद द पैसेज ऑफ टाइम मेरे पास, देखो इन दोनों ग्राफ्स के अंदर दो पॉसिबिलिटी और दो एस्पेक्ट्स हैं। इफ यू ऑब्जर्व हियर एट दिस पॉइंट, तो ये यहाँ से रिएक्ट प्रोडक्ट इंक्रीज होना शुरू हुआ। इनिशियली इट इज वेरी हाई, with the passage of time the rate of reaction is gradually becoming slow। तो आप देख रहे हैं जो डिक्रीज
कांस्टेंट।
आ रहा था, डिक्रीज आ रहा था, वो डिक्रीज बेसिकली जो है वो रिएक्टेंट के अंदर भी स्लो हो गया, और जो इंक्रीज आ रहा था प्रोडक्ट में वो भी स्लो हो गया। यहाँ पर मैं देखूंगा तो यहाँ पर ये एक पॉइंट पे आके रिएक्शन जो है ना, ये स्टेट ऊपर चला जाएगा, यानी कि एक टाइम लाइन पे रुक जाएगा, यानी इस टाइम से आगे कुछ हुआ ही नहीं। यानी कि अगला, इस मिनट के बाद अगला मिनट तो आएगा ना, उस मिनट में क्या रिएक्टेंट नहीं
हाँ।
है? रिएक्टेंट तो होगा ना। बट अकॉर्डिंग टू दिस लाइन अगर मैं ऊपर ले जाऊंगा तो ये तो है। इस मिनट में क्या होगा? इस मिनट में क्या है? रिएक्टेंट। रिएक्टेंट की तो कंसेंट्रेशन ही
हाँ
नहीं है।
ये।
बात समझ में आई?
जी।
इसलिए हम कर्व इस तरीके से
जी जी।
बनाते हैं। एक और कर्व होता है रेट ऑफ रिएक्शन से ही रिलेटेड, जिसमें हम इक्विलिब्रियम के बारे में कंसिडर करते हैं, लेकिन वो एक नेक्स्ट चैप्टर आएगा इक्विलिब्रिया का। इन दैट चैप्टर वी विल बी डिस्कसिंग अबाउट द इक्विलिब्रियम। बात क्लियर होती है?
जी
So
सर,
you
थैंक यू।
observe that the reactant is gradually decreasing and the product is gradually increasing here. बात समझ रहे हैं? So the change is happening. And as we see that the change is happening in the reactants or in the products in a particular unit time, so we'll say that this is known as the rate of reaction, speed of reaction, or velocity of reaction. Is it clear?
यस सर।
Now let's see that there is a thing which is known as the rate expression. Okay. And simply for the rate of reaction, you can also say that rate of reaction is dx upon dt, or you can say that delta x upon delta t. These are the two main things here, dx upon dt and the delta x upon delta t. Why? The dx is basically the small change in the concentration as the delta x, and the dt is basically the small change in time as well the delta t. Is it clear? So dx upon dt is also a form to is also a way to write the electronic sorry, is also a way to write the rate of reaction. Is it really clear? It's a presentation of it. Now what about the rate of
यस सर।
reaction? Let me tell you that if I consider a hypothetical equation, an alphabetical equation here, like m of a plus n of b will be producing the C. What you are observing, I am just drawing this arrow, which is heading only in one direction. That is basically the arrow of irreversible reaction. Okay, that is a presentation of irreversible reaction, which clearly tells me that this reaction will never revert. This reaction will never revert. Is it clear?
यस सर।
What when we'll be discussing about the other kind of rate of reaction, which I told you in the equilibrium, we will be drawing the arrow which is having the two heads. Okay, these arrow basically tells us that the reaction will reverse after a while. Okay, this reaction will move in both of the direction, forward as well as the backward direction. Now in this scenario here, We are only discussing about what? The forward direction reaction. So why? You said that the change in the concentration of product, we can say that the change in the concentration of product as well, but we will be discussing about the rate expression. Why? Let me tell you a law here. Rate of reaction of any chemical reaction always depends upon always depends upon the concentration of the reacting species. Okay.
Okay.
Okay. Now let's see that. Rate expression is what? We have to see this rule here. That is basically a law here for. Okay. And you can say that this is the rate law. Now, what is mean by this thing here, which we just wrote in a statement here? It is saying that the rate of reaction is directly proportional to the reacting species or the active masses of the substances here. What we have here, it means that the rate is directly proportional to the concentration of A and the concentration of B. For this chemical reaction, which is above there, the rate of reaction will totally depends upon the concentration of A and concentration of B. You see the M here and N here?
Yes.
These number of moles will become the power. Okay?
Okay, like for
These
example, we had 3A, so that would have been 3 with the A.
exactly the concentration of H2. I'll be giving you an example here. But when we
Okay.
see that this sign here, when we remove the sign, the two things will come and one is equals to and the other one is the constant. So the rate is equals to K and A which has a power M, the B which has a power N. Now what is K here? K is basically the rate constant. Okay. K is basically what? The rate constant here. Is it clear, Bete? Now let's write about a chemical equation. Let's see that N2 plus 3, no, not this one. Mm, Mg plus O2 and it will be producing the MgO, the 2-MgO. If I ask you that to write the chemical, write the rate expression for this equation, so you will be writing this way, Bete. You write that rate is equals to K, the rate constant, the concentration bracket for first reactor, which is magnesium, the second reactor, which is the oxygen, here it is, and the number which magnesium is the 2, so it is 2. So M and N, it will be 1, 2, okay? It will be 1, 2, and 3 somehow. It will be 1,
Okay.
2, and 3 somehow for us. Sir, are they only 1, 2, and 3? 3 is a rare scenario. 3 is a very rare scenario. They can be 0 as well. Okay, so why these numbers are important for us? Because we need to calculate the order of reaction from it. Now you got the idea that how to write the rate expression. You got this thing?
G sir.
Okay, now let's see that if I want you to write the order of reaction, so what is the order of reaction? It is basically order of reaction is not theoretical value, experimental value. It may or may not be correct according to equation. Is it clear? These are basically the basic explanation regarding the order of reaction. So what is order of reaction? Order of reaction is equals to M plus N. Okay, you can simply say that whenever you have the substances, whenever you have a chemical equation, you will be adding the number of moles there, and you will be getting a value which is basically the 1 2 simply. Maybe the M is 1, N is 2, M is 1, N is 1, M is 2, N is 1. Okay, so the mix order, we have order here like the first order reaction, then we have second order reaction, then we have third order reaction. Then we also have the zero order reaction. Now the question rises here that what is order of reaction, sir? Can you tell me that? What is order of reaction?
Like how we know that M and N are like the moles. So order of reaction tells us how the concentration of particular reactant affects the whole overall rate.
San is era. Let me clear one point to you, बच्चे. देखो, it's not like that कि whenever when someone asks you that what is this thing कि आप उसको एक लंबी चौड़ी explanation सुनाए. Let me tell you, अगर मुझसे कोई पूछे that what is order of reaction, मैं पता है क्या जवाब देता हूँ? It is only the influence of a substance in chemical reaction. That's all. Am I right or not?
जी सर.
It is the influence of a substance on the rate of reaction of any chemical reaction. Let's write this thing. Order of reaction is what? Influence of a substance on the rate of reaction in a chemical reaction. That how much increase in the concentration we will do, so it will influence or it will affect the rate of reaction in how much way. That is basically the order of reaction. Is it clear, bete? Now, what about the zero, sir? Why the zero? Do you have any example regarding this? Any chemical reaction which has a zero order reaction, zero order?
No, not really.
Are you a biology student?
Yes.
तो फिर तो होनी चाहिए शाने जरा मतलब बायोलॉजी के स्टूडेंट होने के बाद अगर मैं तुम्हें मिसाल दूंगा तो इट विल नेवर लुक गुड. Photosynthesis is a chemical reaction in which there is no uh, influence of the chemical substances here, but we used to see that the sunlight has a very greater effect here. बात यहाँ तक समझ में आती है?
जी सर, आती है.
That is the main thing. Because when we are doing the photosynthesis, na, we need water molecules, we need carbon dioxide for making the sugar and oxygen, the starch and oxygen basically. In that case, there is no consideration or there is no reference, there is no influence of the carbon dioxide and water in this chemical reaction, but the total dependence of the chemical reaction is on sunlight. If you provide the carbon dioxide and if you provide the water to the plant in a daytime or in a dark room, it will never grow. Green plant majorly, if I say. Huh? They need the
जी सर.
sunlight for it. The what we say, the green liquid chlorophyll, if I'm not wrong.
जी सर. जी सर.
That traps the light and do the process for making the food and the whole thing, blah blah blah. In the biology, the main thing here is that this chemical reaction is known as the zero order reaction. Why it is the zero order reaction? Because the reactants have no influence. Reactants doesn't provide any kind of the effect on the rate of reaction. Is it clear, bete? So these
जी
chemical
सर,
reactions
clear.
are considered as a zero order reaction. If someone asks you that what is the zero order reaction, you have to tell them. Okay. Now let's see. If I ask you a chemical equation here, give me a minute. Let me write some examples here for you. Okay. So according to the equation, what is basically the order of this reaction? What you observe?
There's one reactant, so mm, the power is 2, and so it's second order.
Okay. Now let me write some other examples for you here. What is the order of this reaction now?
NO bracket 1 and O3 bracket 1. So first order.
Okay, so you are saying that what is the order here for this one,
Where
first
the
reaction? You're saying it's the second order or the first order?
second?
It is the first order reaction because there's only one reactant and it has a total influence. If I increase the concentration, rate of reaction will increase. If I double the concentration, rate of reaction will double. If I triple the rate of concentration, the rate of reaction will triple. So it has only influence. You see, I told you that it may or may not be correct according to the equation. These are the points not
Yeah,
for
you
only
did.
just showcasing there.
Yeah.
These are the points just for the understanding that it is never be the same and maybe or may not be the same according to the equation. But if you see in the second equation, you see that NO has 1, O3 has 1. According to the equation, the order is second. Eventually, when we do the chemical reaction and find out, we observe that it is also the second order reaction. Got it?
Yeah, but
So
like you said that, if we have number of moles in front, we can find out. But
exactly,
they don't.
I told you that you have to add the number of moles of the substances which will go into the power, like the two will go into the power, and we will be considering them as the M and N. But when I just wrote here the order of reaction, I wrote one thing that it is not theoretical, it is experimental value. How we calculate this N2O5 first order? We do some experiments. We do multiple experiments, and we will be changing the concentration of the reactants, and in those reactions we will be observing the rate of reaction as well. And when we observe this thing, give me a minute, I'll show you a screen so that you'll get the idea. Is the screen share available to you, Sanizara?
Yes, sir.
You see the NO and O3 are here, NO and O3 are here, and in these, I just found this question at the earliest in this file, the first question here in the file. So this is basically the value. You see the three experiments are happening here. And in these three experiments, we are changing the concentrations of NO and O3 in the different experiments. Okay. And we are observing the change in the rate of reaction as well. We will be calculating the rate of reaction according to every experiment. Then we will calculate the change in rate of reaction. Okay. We'll calculate the change. These rate of reactions are calculated here. So we need to find the change in these rate of reactions according to the change in concentration. We will be comparing these values in the ratio, and we will find out that what is basically the influence of this particular reactant and what is the influence of, according to the NO, the order of reaction is first. According to the O3 only, the order of reaction is first. But when I compile these orders and I will be going towards the overall order of reaction, I'll be going for the second order reaction. First order from this side, first order from this side. You'll be getting the second order reaction. Is this clear, Bete?
जी सर,
So
clear.
that is how it is an experimental value. It is not, we can say that, a theoretical value only. It may or may not be correct according to it. Okay, it may or may not be correct here. Is it clear?
जी सर.
Okay, let's see that what we have here, that is known as the rate constant. Actually, I forgot to explain this thing earlier. I need to explain this thing earlier to you. What is rate constant here? What is rate constant, Shanizera?
I don't know how to quite explain it.
Okay, let me tell you that. What is rate constant? A rate constant is the K. You saw in the equation earlier, the rate equation. Remember this equation?
जी sir.
This K is basically the rate constant. Okay, this K is basically known
Yes.
as the rate constant here. Always remember that. What is rate constant? Rate constant is basically the, what we say, the constant value here in a chemical reaction. The ratio of the rate of reaction and the concentrations is known as the rate constant for us. Now, let me tell you that what is rate constant and how we will be going for that. Okay, so the ratio of the rate of reaction and the concentration of reactants is known as the rate constant K. Okay,
Okay.
always remember that every reaction has its own particular rate of reaction and its own rate constant. Not rate constant is not constant for all the equations, but rate constant is constant for one particular equation. Okay, let me write this point for you here so that you will remember this thing. Okay, rate constant is different for different reactions. Every reaction has its own rate constant fixed value. Is it clear?
जी sir.
It its value never changes by the change in concentration of reactants. Okay. rate constant will only change its value with a change in temperature. As I see that you're done with this chapter, so you must be remembering some numericals which your teacher did with you. And in those numericals, there must be a temperature mentioned always that this reaction is happening at 25 degrees Celsius, 273 Kelvin, 298 Kelvin, 302 Kelvin. Always the temperature is mentioned in the question. We don't have any concern with the temperature, but the temperature mentioning is making it sure that the rate constant is not changing in all of the scenarios. Is it clear? So the rate
Yes, sir.
constant is always a fixed value. Rate constant is what? Rate constant is always a fixed value. Is it clear?
Ji, sir.
Okay. Now let's talk about the order of reaction again, and then some aspects of the first, second order, and third order of the reactions. Let's say that first order, second order, zero order. Specifically, if I say that if I'm just discussing about a single substance, okay, at first we need to find the order of reaction for one substance, then we'll find for another substance, then we combine the rate of reaction, then we combine the order of reaction. If I say that the first order is here, and I'll be writing the rate expression here, so it's like what? Rate is equals to K and A. For second order, it will be like the rate is equals to K and A square. And for zero, it is like what? As I told you, that rate of order of reaction is what? Order of reaction is basically the influence of a substance in a chemical reaction. So K, A is zero. Are you getting my point? That what we have here?
Yes.
We have
That
nothing
means
here.
that A has no influence.
Exactly. We don't have any
It is
influence of the
zero.
reactant